Very good morning, everyone. I know it's Sunday morning at 9:30 a.m., but I think the session we are going to have is something which will wake you up and probably will keep you awake throughout your career journey. Okay, so we would be starting in next 4-5 minutes. With me, Sagar has already joined. He will be your mentor for today, and I'm sure many of you would have been waiting for this. So by the time I think we still have 3-4 minutes. We are just checking on the system. So the folks who have joined right now, I would say yeah, means whoever your friend or others are to join in. Why don't in the meanwhile you call them up? We would probably be starting at 9:31, 9:32 ish. Okay. So yeah, I think we still have 2-3 minutes. But yeah, meanwhile you could just let me know if you guys can hear me clearly. Is the video quite visible so that we know that the settings are fine, so that we could start well in time. So I don't see any chat or any comment, guys. Can you hear me clearly? Am I clearly visible to all of you? Anyways, it has struck 9:30. So within a minute or so, we will start with the session. So hurry up, call your friends, call everyone else, and yeah, the session would start soon. Oh, perfect. I have got a comment now. So thanks, Digambari. Cool. So perfect, guys. I think good time to start now. It's already about time. So with me is Sagar, and he's a good friend. We were in college together, and we have been part of a journey. He had a journey which I would say many of the students want to live. Many of you would want to go through that, and something which is definitely a lot of learning full, a lot of efforts required, but yeah, means this is something which you should definitely look at when you are trying to create your career. So Sagar had from after graduating from IIT Madras, he was there in Stanford for 2 years, and from after graduating from Stanford, he had been with Google for last 4 years. Okay, and at Google he had been mainly working in machine learning. He has worked on very key projects, and definitely, you know, the products we are using these days, some things which are designed for billions of people, right, are where he has contributed as well. So now he would be sharing a bit of the journey. He would be sharing about the real life projects which matter as a student, for someone to be understood on how you can, you know, use technologies in industry and how is it different from education, the things we learn to what we execute in. Okay, so and thanks, Sagar, thanks for joining us. It's pretty late in the evening there, and it's a Saturday. Great to have you with all of the, you know, the time you have taken for us. Thanks for joining us. So yeah, over to you.
All right. Thanks, Umang. Yeah. So, like Umang said, yeah, we have been friends since undergrad, and yeah, I'm more than happy to be here to basically share a little bit about the kind of stuff that I work on. Like maybe help some of you guys. If you guys have any questions, feel free to ask them at any point of time during my talk. So that said, maybe I can just start with the talk. Uh, Let me just uh, present my entire screen. Let's see. I hope you guys can see what I'm presenting right now. Not sure. Okay, great. So the main focus of this talk is going to be practical machine learning. So, in my journey from when I was like a grad student at Stanford, the kind of machine learning that I learned over there versus the kind of machine learning that I'm actually using right now within Google for building, like Umang said, products for billions of users. So, right from like the autocomplete feature that you see on Chrome or when you're typing in search to um, returning a lot of shopping results. So whenever you search for, let's say, the newest iPhone or the new Xiaomi phone that's out there, or any kind of, let's say, T-shirts you want to buy near you, stuff like that, any kind of shopping query. Um, I have worked on some part of that project, and the kind of results that you see were retrieved by my team at that point of time. That said, the difference in actually the machine learning that I'm using within Google versus the machine learning that I was taught in Stanford, there's like a huge stark difference. So uh, I've the main intention of this talk has been to basically give you an overview of what they don't actually teach you at school and give you an insight about what actually is important and what kind of stuff do I use in the industry. Also, I want to make sure that this talk is broadly accessible. So, if at any point of time I use any jargon which you do not know, feel free to interrupt me, maybe ask me any question. That said, there is going to be some technical component in this talk. So, again, if you don't understand that, feel free to ask me and I'll try to explain it as easily as possible. Okay, let's get started with the chat. So overall, the way I've structured this talk has been first, we'll go over what kind of stuff you learn within school. So to understand what's missing, you first need to understand what is first taught within school. Then we go over some case studies to understand actually how the stuff that you are taught within school is lacking in some way. I go over like 4 case studies, and in the final part of this part of this talk, I'm going to sort of distill that knowledge from these case studies into 5 important factors or 5 important topics that are actually missing from the schooling education. So when we are talking about stuff taught at school, first of all, let's go over why AI is actually pretty cool. So AI is it's clearly the next revolution. As a professor of mine at Stanford put it, it's industrial revolution on steroids. So with the coming of industrial revolution, we got automation of a lot of tasks. Like we got Henry Ford's line for producing at scale cars, and a lot of stuff, a lot of repeated tasks got automated by machines. It's the flavor of the AI revolution is going to be the same, but automation is going to be taken to a completely new scale. A lot of stuff that we experience in our day-to-day life is soon going to be handled by the software. For example, you go to your lawyer for filing any ticket or for filing any legal document. The lawyer needs to go over it, proofread it, correct your mistakes. There's like a lot of legalese that goes into it. All of that can be taken care by an AI algorithm. It has already been shown that AI algorithms are better than like the top 10 lawyers at proofreading legal documents. They are better than the top 10 doctors at diagnosing diabetes. So sooner, like it's going to be a lot sooner than a lot of people expect that AI is going to start touching our lives in a very tangible and in a very definitive way. It is going to make a lot of jobs redundant, at the same time generate extremely new jobs. It's the same as industrial revolution. So I believe understanding the basics and the foundational blocks of AI are going to be extremely important. And if you guys manage to be part of this first wave of AI, because AI revolution is just starting. So I'm not even getting to like the more impressive or cool stuff like self-driving car, which is more of a Western thing. But even within India, like your taxes are going to be at one point or the other completely filed by AI. You just need to submit like your income tax forms, and it will figure out all the nitty gritties. So it's going to start affecting your everyday life in a lot of tangible ways. Maybe it already does with like whenever you order like food from Swiggy, so stuff like that. The second most important point for me is like you can kick ass from your home. Currently, AI is democratizing the power of building your own cool product right from your home. You do not need like domain experts. You do not need like a ton of training data. You do not need domain knowledge for solving a new problem in a completely new field. For example, you have the ability to train a machine learning algorithm that can beat the top chess player without the need of any training data right from your home. Like you can refer to the AlphaGo paper on this. For vision and NLP tasks, earlier we required hundreds of engineers to carefully featurize and train a model. But now you like even if you're like a first year undergrad student, you can sit at home and train a completely amazing machine learning product which can understand text, understand images, and it can do better than any other experts from 10 years back. So this power of democratizing AI, this ability to solve problems, I believe is going to unlock a lot of very, very cool, very new products. And that's why I feel AI is just pretty cool. From like even a first year undergrad student can now go and build something that can change the world. That said, this just to basically get you guys a little excited about this whole field, and let us agree that it's like a cool topic. So now I also want to cover what is taught within schools. So roughly, any machine learning pipeline has three components, like the data part of it, the machine learning model, the actual model which learns from the data, and the evaluation of this model. So this is the general structure of, like, it's a very simple general structure of every machine learning pipeline. So within the data part of it, there are like a bunch of different things that are taught within school, like how do you get insights from the data, like basic insights. Usually data is noisy. If you collect real life data, it's going to have a lot of missing values. How do you handle that? How do you manage, massage and augment some of this data? So this is like very simple data side stuff. Then on the machine learning side, you have like linear algebra, which is actually the engine of this machine learning model. Then how do you choose a correct machine learning model? How do you play with its objective function? How do you tune all these knobs that are there in a machine learning model? So all these things are covered in the machine learning model part of it. And then finally, the evaluation of it, like how good is it doing? What's the accuracy? What is the importance of different features within the data? All of that is taken care within the evaluation part of the pipeline. So in school or in research, roughly 90% of the course will be on this machine learning model. 10% of the course will be on the data part of it, and evaluation of it will be given like just a side glance. There will be like barely any, if any, talk done on the evaluation part of it. As I like to say, usually students know about the evaluation when their midterm results come in. But in the industry, if you take a look, 80% of my time is spent on the data, 5%, and if that, on the machine learning model of on the machine learning part of it, like choosing the machine learning model and stuff, and most important, and 15% on, let's say, the evaluation of it. So you see the stark difference. In research, we are focusing 90% of our time on the model versus 80 versus that's like the least important in industry. The most important part of it is actually data. Like, how do you understand your data? How do you featureize it? So I want to explore this difference in the industry and in school/research a little more. So what's lacking? Like, why is there this difference? So the company settings and the research settings are actually very different. So I want to go through some actual case studies, some actual examples to make you guys understand like how practical machine learning and research side machine learning differ. So like the first one is like the Quora challenge. So Quora is this website where you ask question and where you get some answers for that question from anyone on the internet. So what the executive team on Quora found was like a lot of these answers have these images, like these images where person has added an image to maybe add on to their answer. So they wanted to understand if we can use this image data. So first of all, they wanted to understand what kind of images are the users uploading. So at a very high level, they basically said that can you guys just classify these images into what kind of landscape there are? So I've added 3 images over here. Like the first image was a lake, the second is a large city, probably New York City, and the third one is like grasslands. So this task might seem very easy for you as a human, but for a machine, this is a very hard task because images aren't always high quality. The data isn't available for all the classes. So usually what you would think is, let's just collect training data for each of these classes and then just train a machine learning model on top of it, and let's see what it spits out. But like these images are going to be uploaded from the mobile phones of a user, maybe like, so they'll have like distortions and scaling and occlusions, and like a person taking a pic from a handheld camera is not going to take like this beautiful a pic. Like it's not going to be that high quality. So in general, this is not a trivial vision task, like where you want to classify the landscape within this image. There can be multiple landscape. Like for example, in the first one, there's a lake, and in the background there's a mountain. So how do you figure out what to do? So most engineers actually just try to, like I said, collect a bunch of this training data and throw it at a machine learning model and then see if it can spit out the correct class for a landscape. So this worked pretty well. It gave like an accuracy of 70% or so. But people weren't happy with it. Like they wanted, like 70% is neither great nor bad. So they wanted to see if we can figure out a better solution for this. And one of the engineers actually figured out a very, very simple solution for this. So what they found was, whenever you click an image, the phone actually stores a little more metadata of your image on top of it. So it will store like at what time was the image taken. It also stores the location. So it makes it easier for you to sort and figure out, okay, you have taken all these images from Goa, stuff like that. So when you open your Google Photos, it sometimes sorts it for you. It sorts it by this additional metadata information that your phone stores whenever you click a pic. So what an engineer figured out was like there's latitude and longitude information present on these images. So why not just use this lat and long and do a direct lookup on the maps as to where this actual photo was taken? And if you know where this pic was taken, you just look out what's the geographical feature next to it. So is it a lake? Is it a larger city? Is it like a grassland? Is it a desert? So with just zero AI component in it and like literally just doing a lookup, okay, this lat and longitude is a lake. With just this one simple task, they were able to get 100% classification accuracy on this task, rather than the 70% of this complicated machine learning model, which most engineers were trying to train. So this is the first case study that I wanted to show you. The second one was basically, there's a startup which was giving you a safety score for your driving. Like they were looking at your driving pattern and trying to figure out how safe do you drive. Are you like a very reckless driver, or are you an extremely safe driver? This data could potentially be used in, for example, your auto insurance. Like if you're an extremely safe driver, then you should essentially end up paying very small amounts for auto insurance. So what they wanted to do for figuring out your safety score, like they wanted to see where do you live, because your location, like if people around you are risky drivers, then you end up being like you cannot have a low safety score because someone else will crash into you. So figuring out the home location of a driver was kind of an important thing. So one engineer was given this task: can you figure out, given the entire driving data of a person, where does this person live? So it's the same. Like this person took the driving data of 10,000 users, and the label was like their home addresses, and trying to see if you just throw the data at this machine learning model, can it figure out what the home address is? It turns out it does not do again that well. It gives like a rough 70% accuracy. The engineer spent a lot of time on trying to debug the model, why it's not giving 100% accuracy, or at least better than 70%. The engineer was not able to actually again figure it out because deep learning models are complex. It's hard to debug why it is doing some predictions. Then lightning struck, and the engineer came up with a very simple solution. Let's just take a look at where the car is parked at 2 a.m. at night. Wherever the car is parked at 2 a.m. at night, that is very likely to be the person's home address. And again, it just worked brilliantly. Like it gives like roughly a 98, 99% accuracy in predicting where the home address is. And this is a solution that they are going to probably use in their production system. The third case study that I want to talk about is the Facebook one. If you guys use Facebook, most of you are aware of Facebook.com. The business model for them is they show ads for you. I was getting this one ad by AT&T, which is like a mobile carrier like Vodafone and Jio. So I was trying to see, why am I getting this AT&T ad? I just click on that and I say, why am I seeing this ad? And Facebook gives me a really nice, clean explanation that, okay, AT&T is trying to reach to people above 18 years old and who are living in California. That's a very human, understandable explanation. So when I'm using a product, I expect this kind of an explanation for the product that I'm using. So having this interpretability, this understandability of why an AI model is doing something is actually very, very crucial and very, very important. Again, this is something that you will not hear about when you take a standard machine learning course in your university, or you're logging on to Coursera or Khan Academy or any of these online course certification programs. So this is some of the knowledge that is actually, as a consumer, you are very well aware of. Like you want to understand why AI is taking some decisions that it is. For example, you can imagine there are some companies which are trying to automate the process of resume selection for a job opening. So basically, what's going to happen is the AI is going to start rejecting candidates' resume automatically. If you do not understand why AI is making these decisions, is it using the gender, the race, or the religion of a person, then that's a huge problem, right? Like if it starts rejecting all women from, like, let's say AI engineering roles, then that is a problem that we need to correct. We need to make sure your AI algorithm is not learning these features, or it's not picking up on these things and sort of promoting these biases. So understanding the decisions and classifications done by AI is of utmost importance. So that's again something which is not really well taught or well understood when you are doing a graduate program in artificial intelligence. And this is something the Netflix prize, the fourth and the final case study that I want to talk about, is the Netflix prize, the Netflix competition, which happened back in 2007. So Netflix decided to anonymize and open source all their a huge chunk of their user information, user data. So, for example, they anonymized the username and said that someone saw Three Idiots. Three Idiots is a movie about a group of friends, and the user 1234 rated it as a 5-star movie. So given, let's say, the user ratings for 10,000 movies from 10,000 users, can you predict what a user is going to rate a new movie that comes up. Netflix said that if anyone can do better these into five headers like engineering and feature engineering. Sorry, is there any question right now, or are you guys following up to this point? Okay. Hmm. Okay. So, okay, I will continue on then. So the main topics that I want to cover, like the five important topics that I want to just give a brief chat about, is like the data engineering and the feature engineering. So this is a very important thing. Like you should make sure your data is correct. You should maybe massage it and extract relevant features. Like in the understand what additional data can you get, or in the car location, can you just engineer a very simple feature like where the car is at 2 a.m. So all of these things are sort of fall under data engineering and feature engineering. These, according to me, this is some of the most important stuff that you need, that you as an AI engineer can do, and it leads to the largest improvements in your product. There are some simple sanity checks. Are you using the right kind of data? Is there anything else from outside that you can use to solve? Is there like a simple solution that you can use? Um, in general, you don't want to just throw stuff at a model and see what it learns, and um, see if you can probably give it like smart features which you as a human intuitively will use for making these predictions. So data engineering and feature engineering are like crucial part of your day-to-day role. Interpretability, like the decisions of an AI should be understandable. We should understand the features that an AI is using to make these classifications. Like in the case of automatically rejecting candidates' resumes, we'd like to be sure what the reason for rejection is. It shouldn't be based on gender, race, or religion. Um, so understanding how and why the AI is making these decisions is very, very important. Um, Repeatability and reproducibility. So essentially, if I retrain a model on the same data under the same conditions, I should get the same model output. This is one of the hallmarks of science. If you don't do this, essentially, I doubt you are doing science. So this is like one of the core things that you should not break. In production environment, models need to be constantly trained. Like you every like 3 months, Facebook might update its model for click predictions. Amazon might improve its model for shopping recommendations, like the kind of products you get. Google might update its Google search engine, so stuff like that. Every 3-4 months, the model has to be retrained again. So if on training number one, your model gives amazing performance, but if you retrain it and the model performance drops drastically, you essentially cannot productionize this model. There is no way this model can lead to a actual product that you can deploy and like billions of users or millions of users can use. Monitoring and debuggability. So whenever whenever you productionize a model, it's extremely crucial that you're able to monitor it. Debugging basically involves understanding if there is a bug and what is the cause of the bug. Being able to monitor and debug a system is very crucial for any system that you build, let alone an AI model that you're building. For example, Twitter lost millions of dollars in ad revenue because they were not able to capture a bug early on. Like the bug persisted and they were not able to get it at the onslaught of it. So if an AI model's predictions have started to go haywire, you should know about it and not like months later. So being able to constantly monitor and debug are very crucial parts of AI model, and you need to be sure that they are sort of baked into the model. And finally, privacy and fairness. So users' privacy should not be compromised when models are trained. So an example of this is actually still the Netflix price. So when Netflix decided to open source the user data. They thought that they will anonymize it by just adding by hiding the usernames and adding user IDs. What they did not realize was, like, if you take the Netflix ratings that a user has given and compare it with open source ratings, let's say that they did on IMDb, like they rated, like if someone has rated 5 star to Three Idiots and 5 star to Do Bigard or a few other movies, and they have given very similar ratings on IMDb, then I'm going to be pretty confident that it's the same person who has given ratings on Netflix and who has given ratings on IMDb. So I'll be able to uncover the identity of a person like this. So making sure that your AI model does not uncover the actual identities of a user is going to be extremely important. Um, Finally, like African Americans who are affected by racial bias in healthcare, they were being not provided the same healthcare recommendations by the AI model that was recommending a program to a person who was sick, um, depending upon their race, which was a big problem. Amazon's hiring tool had a bias against women. Facial recognition AI had a bias against Asians. So there have been multiple problems where if you just throw training data at a machine learning model, it turns out that the model learns something that you do not intend it to, and therefore being constantly aware of these privacy concerns, these fairness concerns are extremely important for an AI engineer. So um, roughly speaking, these are way more important things for you to understand than almost anything that you have studied when you were in when you are studying these things in school. Um, so yeah, with that said, I think so. I will open up the time for folks to ask me questions, maybe, and if you have anything that you would like to maybe ask me about the whole talk.
Cool. So, sure, Sagar. So I think we will just start. Sure, Sagar. So I think first we will start the some questions from my side. I think by the time people please start posting it in the chat, we will pick it up. Sagar is here to answer them. So first thing, Sagar, pretty interesting. You mentioned about some of how 80% of your time goes in data and 5% on machine learning, and then 15% on implementation others. So why is it not? What do you think? Why is it not taught in education environment? Why the education so differ? You have learned at IIT Madras, India's one of best. You have learned at Stanford, the world's best. Okay, people who are teaching at Stanford are the guys who are creating new systems, and you are finding gaps there as well. So where do you feel are the misses? Like what is not getting rightly addressed? What do you think?
So usually, what ends up happening is um, data part of it usually has very simple solutions, and that is not really a cool thing for research. Really, at the end of it, research has to seem like like you're doing a lot of maths to it. But actually, a normal AI engineer's everyday role does not involve a lot of math. It actually involves problem solving. Like you have a very concrete thing. You want to build a product for, let's say, delivering something. So you want to figure out the person's locations, at what time is the person interested. So there are like a bunch of very simple things that end up working, and they end up working amazingly well. It's not just like they give you like small accuracy improvements. It will be a solution to 95% of the problem, and the last 5% is just essential incremental improvement. I'm sure, like, you work as you are working in a startup, you don't really want perfect solutions. You want solutions that like just solve the problem and you get working at them. So that's the dichotomy between research and industry. In research, you want like these really elegant looking clean solutions. In industry, like saying at 2 a.m. is a perfect answer. You will never get a research publication if you publish a paper with this thing. So that's, I think so the difference is the objectives are different. Like industry wants to solve a very specific problem, however simple the solution is. Research wants to do something cool. So each one is in its own place doing well. I think so long term, the focus of university of doing something cool and something hard is going to pay out, because you want, like, that's a very long vision. It opens up like new machine learning models, new machine learning algorithms which actually learn better, which learn like humans. So with the long term focus of universities, it misses on like really simple solutions. And industry with its more like, let's have a solution for the problem right now, it gets those solutions but has a does not have an eye on the long term vision. So they in essence work in a synergy. But if you are looking for being an industry side AI engineer, you need to be aware of these core important things. I mean, I think so. AI is going to have everything to do with privacy and like cybersecurity and all these aspects. So that's actually very it's a very fair point that you have raised. Like in terms of cybersecurity, at least you want to be sure that your AI does not expose the data on which it is trained. You want that separation between the actual user data that you have and the kind of model that sits. So if your model is just predicting the user's data, so if you give it user ID and it predicts what the value is, then that's a very horrible use case. So you want to be very conscious about how your AI is training and how and what kind of stuff it is learning, because it might end up exposing a lot of your it can end up exposing a lot of issues that are present in your system. And if you train it incorrectly, like I said, it can produce bias against women, bias against minorities, especially in a country like India where the percentage of people who actually use internet is not at all representative of the actual ground truth. You have like very you have a we have a, like we have a huge section of minorities who actually don't end up using internet. So if you train a model on the kind of like folks who are using internet, like based on let's say online survey forms, like you take what kind of like you take a survey as to where people like to go and have food, let's say, and based upon that try to predict where should you make the next Starbucks or where you should make the next restaurant to open for your food chain. That's going to give very different results because most people in India do not use internet. So it's going to underrepresent, let's say, minorities. It's going to underrepresent people of color. Stuff like that.
Then the next thing which I wanted to just understand quickly was you mentioned about problem solving, right? And that's the key to, I think, most of the requirement, especially when it comes to machine learning, because you are first trying to understand the problem, then probably get the data, and then probably fit a model to that, right? So, and these are the things when, as you said, research is the cool thing, not probably understanding of these kind of problem solving concepts and all. So, as a student, if I am looking to probably be industry ready, okay, what are the things which I should focus along with, say, probably just learning a course? Because unfortunately, many things which are there just teach me probably concepts, will teach me few algorithms. So, what should I do along with that?
So I feel like throughout the talk, like what I've tried to showcase was the kind of solutions that you end up implementing are actually very, very straightforward. Something that you need zero math background for. Like you just need to understand how humans work, right? Like humans park their car at their home. Like that's a very, very basic thing. And machine learning model actually needs a lot of data to pick that up. So as a student, if you want to actually ace some interviews, if you want to impress someone who is going to take an interview for you on artificial intelligence, the biggest let's say sign that this person actually knows AI is if they have done something and actually knows some of these concepts. When I take interviews of students on artificial intelligence or stuff like that, uh, I need to understand if users, if that interviewee has seen or actually implemented and seen the kind of problems actual production AI systems have. If they have actually played around with AI and have built something which, let's say, thousands of people are using, they will come across all these problems. Like everyone is using a different type of mobile phone. So one is using Android, one is using iOS. They give completely different signals to the model. They give completely, like each one is using is using a model in completely different areas. Their use cases are completely different. So the kind of stuff that your machine learning model is seeing is completely different. So if the candidate, like interview candidate, is able to get this across to me, I feel that's a very, very strong signal that this person has played around with AI, has actually seen what uh, problems in AI look like rather than just done assignments. Like assignments are good to understand, get the foundation of AI, but usually you want to go above and beyond that. So yeah, so basically, if you have seen any of these problems, I'll be very impressed.
So essentially, getting your hands dirty, use human intelligence along with artificial intelligence, then that would be essentially a better way rather than just thinking that I am doing all the problems, but why I'm not getting a job. But the reason could be that you are not applying yourself with the concepts, applying here, understanding the human aspect of things, just not machine aspect. Awesome. Now, one question has been asked by three people. Okay, and I think you are one of the best person to answer that. You are from mechanical engineering background, and the question which is asked by Chinmay, Aniket, as well as Akshay, is that what are the opportunities or how can we learn machine learning? What are the opportunities for mechanical engineering in machine learning? So, what are your thoughts?
So they are doing mechanical engineering and they are interested in machine learning. I, I feel that's the largest area in which. So I am a machine learning engineer. I have like a soft spot like for mechanical engineers who are doing machine learning. Um, Currently, our industries are working on tech that we have developed in 1960s, where machines do very, very specific tasks. Or if we want to, for example, figure out if a machine has started messing up, if it's broken, we have to actually go inside and check something. Like, and usually, for example, recently Tesla had to recall a bunch of cars. Same with Ford. Like a lot of these big car companies have had to recall cars because they did not detect the problem until like some car exploded or something. So with AI, you're going to have this built-in monitoring into it. So building solutions for these kinds of problems are very, very possible. You don't need humans to go every now and then and supervise and check what's happening, but AI will essentially take care of that monitoring part of you for you. Or Intel is building this extremely interesting supervision part where you are trying to see when do employees need certain help. So basically, they are doing some stuff on customer care side. So, for example, when you have an issue with your refrigerator, you go and call some some call person like for figuring out why your refrigerator is not working, right? Um, all of those questions can sort of be answered by an AI. So in your day-to-day supply chain, in your day-to-day industry, there are so many problems that can be solved by AI, which we like. All of these are extremely low-hanging fruit because AI is like a very, very at a very, very nascent stage. We have just started. We have just started on the AI revolution, and uh, I think so. Mechanical engineers specifically are also very well placed for solving a lot of these problems, building really, really cool products and Yeah, like there are like a ton of mechanical engineering problems which can be done like by AI tools. So yeah.
Pretty cool. I think that kind of gives an idea that again, coming. I think everything's coming down to that point that as a human try to identify issues, then use the tools to fix them, and whatever tools fits best. If it's AI, of course, use that. Otherwise, use anything else. But yeah, given AI, you can build much powerful tools, much powerful inspections, and also there are like a plethora of opportunities which opens up. If you are a mechanical engineer with AI power, you can actually do a lot in mechanical fields. Awesome. So,
Like I know Waymo requires a lot of people who have an intersection of mechanical engineering and AI. Planis, which is like India's homegrown detection technology, which does like non-destructive evaluation. So it goes and sees if your pipes are doing all right. It uses a lot of AI algorithms to figure out if there are cracks in a pipe or if there are leakages at some point of time. They did like a whole evaluation of the largest, I think so, Reliance plant in Maharashtra. They basically evaluated whether the plant was safe to operate or not. Usually, this needs like months of human effort to actually go and take a look at pipes, like all the pipes, whether they have like good amount of pressure, whether there are no cracks, and all this kind of stuff. Like the bot was able to do it within a few days or something. So it just opens up so many extremely cool things. And mechanical engineering is a field which is sort of broadly applicable to any industry, right? Like if you're manufacturing something, AI will just help you manufacture that at a much larger scale.
awesome. So right now, just as you mentioned, say for example, crack detection or detection of an anomaly. So mechanical engineer knows how to define that crack, and if that guy then uses AI, then they get the data and then fix out saying that okay, this is a crack using AI. So that's how a mechanical engineer definitely could play amazing roles because the human inspections, the tough works are all taken by AI, but along with the mechanical things because a normal person.
Knowledge guide the AI algorithm. Yeah.
Should I consider applying for a master program in computer science if I am a mechanical studying bachelor's in mechanical engineering right now?
Um, I think so. You should seriously consider it. But that said, you need to like this is now from purely a graduate committee application processing point of view. Like as a graduate committee, I see that you're coming from mechanical engineering. You want to get into computer science. What kind of evidence can you show me that you actually have an aptitude for computer science? So it should reflect in the kind of projects that you have done. So usually every project you can see what the motivation of the student was to pursue that project. Whether it was to solve a cool problem, whether it was to design a very interesting machine learning algorithm, whether you want to actually do good for the community. So there are like a bunch of different like motivations why you have done a particular project. So with the kind of like with a mechanical engineering background, if you are trying to switch to computer science, for me, like the motivation was that I wanted to solve school problems, and whatever way I can, I will do it basically. So, as a computer science engineer, you get like scope on working on like a wide variety of industries, and computer science just gives you additional tools to solve problems, and that's the angle with which you want to sort of approach this. Like if you are someone who is able to showcase that your transition from mechanical engineering to computer science is like the most natural step for your career, that's then I'll encourage you to apply for a computer science degree. Then that will be helpful.
Got it. Great. So Arnav then has asked, as you have mentioned, to play with AI. So many questions is from where I can play with AI as I'm still learning MLA. Essentially, he wants opportunity to understand what are the platforms to play. And I think a relevant question is asked by Chinmay: is Kaggle a good platform for practicing ML problems? So yeah.
Kaggle has all the problems that I have been talking about ML. Like It will be good to get your hands dirty at the very, very beginning, but it's the same. Like the data has been massaged for you. You have like a very, very nice data set, and you have a very clearly defined problem, and you just apply different machine learning algorithms one after the other to it, and then you see which one of the machine learning algorithm works. That's good. That's definitely something that usually you end up doing in research, but that's not what actual ML engineers end up doing. So what I would recommend instead is, if you're doing Kaggle, maybe take one of these problems and try and actually building a real life solution. Like if you are, let's say, building a classifier for figuring out where if there are like dogs in your home, try to see, basically try to maybe take camera and actually see whenever, like whenever, if it can detect dogs around you, like actually see the kind of video streams that you will get, then you will understand that the data that you're getting from these video streams is very, very different than the nicely curated data set that is present in these Kaggle competitions. So it's a good point to get started. But if you really want to make a mark, I will say actually get your hands dirty, and that looks like amazingly well on your resume. Like if you showcase that you built an actual cool product, like let's say only 10 people are using it, like no more than 10 people are using it. That looks way better and it stands out very clearly on your resume than something that like you did XYZ on your Kaggle competition, like you're the top performer. That's good, but I'll prefer someone who has actually worked with an AI algorithm and seen that okay, sometimes the camera switches off, sometimes the camera is like the electricity is gone, therefore the camera just does not get any feed. So you have all these weird issues which start popping up, which you just won't know if you have a nicely curated data set.
I think this again brings down one interesting point is that what you said, get your hands dirty, and what Arnav has asked, where should I play? So your play on MLA could start from your home. Pick something interesting, try to get some data out of that, and try to execute on that. And I think many times people look for easy answers. Trying to understand ki, if I read this book, will I get this done, or if I see this video, will I get this done? But I think the thing is that you have to implement things yourself, get your hands dirty as you said, and then only you could get to the places where you want to be. Otherwise it always be like you will feel that I learned it but still not getting it because you did not do the hard yards, probably, or sometimes simple yard. Start from home and start executing. So this is, I think, very insightful for the people who actually want to do something or build something on their own. So then Yugandhar has asked, I'm a mechanical student compared background. We get less priority in IIT industries. Any suggestions on that?
So lower priority on IT industry. So again, like I said, even in a role for IT, the core part of the talk still holds true. A lot of the problems that you're actually doing, they need very, very simple solutions. The only important part is actually going above and beyond and actually trying to find that simple solution. So um, if you are from mechanical engineering background, it's completely fine to get into like this IT CS industry. Uh, you should be just ready to put in a little more effort, I would say, at the beginning of the thing. But at the back of your mind, know that this problem is actually easy to solve and it does not require a lot of undergrad background in CS. What it needs is just for you to think with human intelligence, like human said. Um, and and you'll be fine. Like I think so mechanical engineers in IT also will be able to perform well. But again, just being smart about it and think through the problem. Yeah.
So another student has asked, Manivas has asked, since deep learning models perform way better than traditional ML models with availability of enough data and enough computation power, why traditional models are still being used?
So, like I said, like in all of the key studies that I've given, the Deep learning model was not able to. Deep learning models are doing better than traditional models on all these curated, nicely done data sets, like by far. Like neural, like machine translation, all these problems, you will never think about doing anything else other than deep nets. But for most of the real life applications, for a lot of real data that you get, there's a lot more that you can get from a traditional machine learning algorithm than from a deep learning model. Like you can understand the kind of decisions that a traditional model does, but a deep model, it's all a black box for you. Like if it's like in the candidate resume case, if it starts rejecting some candidates and you don't know why it's rejecting even one candidate, if it is doing on the basis of the gender of, or if it is taking race or if it's taking religion as a feature or rejecting a candidate's resume, then that's like a multi-billion dollar lawsuit that you have to fix. And as an AI engineer, having worked in a lot of these things, that's a much bigger consideration than that 1% increase in accuracy. Like I really don't care about that 1% improvement which is being shown. I'm more I'm more like more important for me would be if the privacy concerns are not there, whether it's a fair model that I've trained, if there's no bias in the model, whether it's an understandable model where over time you need to keep improving the model. With a deep learning model, you end up retraining the whole thing because you don't know what the model is doing. So you just throw more data at it and hope it does better. With an interpretable model, you know where the model is lacking, where it is making a mistake. So with an interpretable model, which is more or less or most of the traditional models, um, you know how are you going to improve the model. With more time and more effort, you're going to get consistent improvements in the model's accuracy. But that's not the case with deep models.
Interesting. So, I think, yeah. Then moving on to the next question, Aniket is asking, what are the major problems you face today while working as AI engineer?
Like I said, like data, it's always about data. Like uh, Google is such a big system. You are it's a very complicated system to work in, and sometimes a pipeline somewhere very far away fails, and now suddenly your AI model is not getting one feature completely, which was a very very important feature for you. So now you need to spend 80% of your time figuring out why is your model not getting the data that it should get, and you spend 80% of your time just debugging and trying to figure out that one line of code which went wrong. So it's all about the small, simple things which you need to do perfectly well. So like I said, like one of the most important characteristics of an AI engineer is attention to detail. So more than your undergrad, more than like what you're like, whether you're mechanical engineer student or CS, if you can pay attention to detail, if you can like when you're debugging your code, when you're debugging why your model is not performing well, if you can figure out, okay, this one line is the problem, that's all it matters. So that's the most important thing. And that's where I spend most of my time. Yeah.
So many people see things as pretty awesome in terms of as you said probably from a mind perspective, research perspective, and all that. But when it comes to real physicality, things are different. So sometimes they're uncool, sometimes they're cool. But I think the enjoyment is in coming finally out of the coming to a solution and executing something, which probably.
Finally want to solve a problem. Like I honestly don't care how I solve it. As long as I'm able to help people, I'm able to get a really cool product out. That is all that matters at the end of the day for industry. So and AI is just a means for getting that. If you have like a very very stupid thing which does not use AI, but it gives you 100% accuracy, why will you not use it, right? Like if you have a completely non AI solution which is 100% of the times right, like anyone with will just use that, right? Like why not?
Going to the next question, I think we'll just pick. I think there are simpler questions now. So AJ has asked about a question which he's okay. Sorry, I think I lost some questions. Yeah. Any videos according to you we should see?
This depends upon where you are at in your AI journey. Are you a very beginner? If you're a very beginner, then like the foundational courses like CS 2 to 9 are very very good. If you are more on the expert side of it, there are like a bunch of system design courses on YouTube which you should take a look at. Like, just go and search ML system design. There will be a bunch of really really cool channels that you will get to know about. So yeah, just depending upon where you are at what expertise level you are currently at, pick one of those two.
Perfect. Now, I think this would be a last question then. Manivas has asked a basic question. Is there any difference between data scientist role and ML engineer role?
There's a huge difference. This depends very much from company to company, but in my own personal experience, data scientists are not engineers in some sense. Data scientists are scientists. Like their role within a company is going to be more like um, our new users are not able to we are not able if you have this really really cool new social media app, let's say like a competitor to Facebook, but people are coming on it and 2 days later they are signing off, like, and they're never coming back. Like a huge chunk of your new users are not doing well. So data scientist's role would be basically to try to figure out why this is happening, like what's the reason why new users are coming on your product and not sticking. So why is the stickiness of our product low? So it can be like our onboarding process is very very bad, or for new users the kind of stuff you're recommending is very very bad, or on like let's say on the product there are some features which are messing up. So on answering the why part of it is what a data scientist does. An ML engineer takes that answer or takes that intuition. Let's say the intuition is that the when that new user is coming on your social media platform, it they have no friends or they have no interest that they are following. Right, they are new users, so they have nothing that they are following. So the recommendations are extremely horribly bad, and that's the reason why new users are messing up. And an ML engineer will take this intuition, like, okay, so the new user has nothing to explore and solve that problem. So, how do I make some relevant suggestions specifically for a new user? So, I will maybe take a look at some of the things that some users around them are doing. So, maybe recommend some local news to the user, which might be relevant, or some local events that are going on around the user, which might be interesting for them. So an ML engineer will take that intuition and propose a complete solution. So data scientists figure out the problem, ML engineers engineer the actual solution. That's the rough distinction.
Wow, I think one of the key thing which is here is that given there's so many roles over here, and given almost everything sounds similar, either something is sub part of something or it's like whole of it. The nomenclature could be very confusing at times, and frankly, I also didn't know of it, but seems like a very two different kind of job profile themselves. So
Differs company to company. Like given like how we are confused of data scientist and ML engineer, a lot of CEOs are also confused about data scientists and ML engineers. So just take that with a pinch of salt. There will be some companies where there'll just be data scientist role opening or just ML engineer, and that person has to do both of these things, like answer the why and write the actual solution for it. So you just talk with your recruiter and actually ask for specific details as to what this role entails. What are the responsibilities? What can I talk to someone who is in this role and understand what the day-to-day stuff is like? These are all very fair questions to ask the recruiter for a role. Yeah.
including it. Yugandhar has asked, what are the topics we need to concentrate more to become a ML engineer? I am assuming he is looking from a what is it, guidance or topics wise, courses wise point of view, probably.
Again, this I don't know where you are at on the expertise level. Have you finished your undergrad? Are you just starting your undergrad? Are you finished done with your grad? Where are you in this?
Students are undergrads studying themselves. I would assume if you mention, so we'll take it up. But yeah, right now let's take
Assume you have no background. I would say like take up the CS 229 course, learn the basics of machine learning. Um, Within machine learning, have a solid understanding of linear regression, logistic regression, all these very, very simple models. Like you need to understand them inside out because most of the current industry runs on these models. Like deep learning and all these things are extremely cool and they are clearly the future, but they are still a very, very huge black box. And I will never question you on deep learning. I will question you as to can you do these simple things? Can you get simple insights out of these models? If the models crash or if the models have to be updated, how do you go about it? So, if as a beginning machine learning engineer, I will say just focus on the simple models, learn linear regression, logistic regressions very, very well, understand k-means, all these very, very straightforward things before you jump into deep models or any kind of deep learning, I would say. That's my recommendation. Just do the foundational courses.
perfect. So I think this kind of sums up the questionnaire part. So Sagar, having spent 4 years at Google and probably you are forefront of at the forefront of technologies. You are working on probably the latest algorithms might be your latest technologies coming out. So what are your thoughts on present engineering student? And you have seen through Indian academic system also, and you know how a undergrad student is in India and what are the opportunities out there. What do you think Indian student can be more focused on right now? And yeah, means any suggestions or any thoughts on how things could be better for them, or how can they be ready for the opportunities which are there and they might not be even aware, or they might not be ready for those.
I think so. Going forward, a lot of like I'm going to focus on like engineering. So let's leave lawyer and doctor and all these professions out of the focus because again I personally don't have a lot of knowledge, but I have done engineering, so I understand that field very well. Um, I think so. CS in general is has like huge scope. So if you are just done with your 12th standard and you're making that decision which engineering field to take, I think the computer science in general is extremely hot in demand, and it's going to stay like this for the next 10 to 20 years. So if people are saying that computer science is going to go away in the next 4 or 5 years, I've been hearing about that since 2010 when I was making this decision, and I can assure you it's not. Um, Machine learning, computer science. So what's going to happen is computer science start going to affect all the other areas. A lot of like the core mechanical part of it has been already done. What we need to do is we need to make computer systems, make mechanical systems better. And for making mechanical systems better, we need to add intelligence into this. So there's this whole field, like let's say in mechanical, called intelligent manufacturing, which is, according to me, going to be something big, where you are able to manufacture something smartly, where the machine, instead of doing just like one task, like on a conveyor belt, each machine does exactly one task of like, let's say, punching a hole, another machine will just weld something, another machine will join stuff together. So stuff like that. With intelligent manufacturing, you'll be able to do much more tasks by a single machine because it will be able to take care of like small deviances instead of being able to do exactly one specific thing. With an intelligent machine, it will be able to with an intelligent machine, it will be able to broaden the capabilities that it does. So, as a computer scientist, you will be the one who is building in this intelligence into the machine. So right from intelligent manufacturing to, let's say, VR and AR, with gaming becoming really big, VR and AR are going to be the next forefront where there's going to be a lot of breakthrough. Facebook is investing a lot of money in Oculus. Microsoft is doing the same with Xbox 360. So VR and AR are going to be extremely important things that are going to potentially come up in the future, and not just distant future, within 5 to 10 years. And as a computer scientist, again, or even as a design engineer, you'll be able to build a lot of these systems for VR and AR, make them scalable. How do you play games within VR AR? So that's one more thing. With self-driving car, at least coming to the Western world, that's going to be a very, very important entire new industry which is going to be created with a whole new set of jobs. Um, how do you perceive things? How does a car perceive things? How does LIDAR? How can you improve the accuracy of LIDAR? So stuff like that. So in general, I will recommend computer science as the field, but you need to be um, broadly more capable of just problem solving. Because all of these things are very, very cool new stuff. There is no research that's done there. This is all cutting edge. We are like sort of literally living in the future right now. And this is not steam engine technology. This is not something which has like just 0.1% improvement, or there is some old guy somewhere who is tinkering around to make the like petrol slightly more better at cleaner burning and stuff like that, or get more energy from gas. This is like completely new broad technology which is going to multiply by a factor of 2 every few years. It's going to double every few years. So the AI wave is just beginning in some sense. So I'd recommend, if you want to even go into a field like biotech or medicine, AI is going to play a part there. Like I said, like diabetes detection, AI can do that better than the top 10 doctors within the year. So the top like 10 doctors from the most respectable hospitals, and then they gave them an MRI of a person, and they were not able to detect like whether this person is going to have diabetes or has diabetes, and AI algorithm was able to do that. So it's I think so. It's going to start at the applications of AI are just beginning. Um, as an practical machine learning engineer, you'll be able to take all this research that's been done and actually apply it with some common sense solutions, some tinkering, like very, very simple tinkering, and actually build a very, very smart product out of it.
The opportunities are opening up in all the spaces. Computer science is definitely going to be backbone, and as you said, AI is something which is redefining things. So interesting. I think we are almost at the end of the session. Any parting words, any things which you want to leave the students with, as probably food for thought, or anything, your suggestions on which they should work on? I think that would be great. Yeah.
Like I guess just don't be like for problem solving. Like a lot of us start the journey by the most simplest things, and for if you are getting into any field, I think so. This advice has helped me at least. Like it's okay if you're starting late, or if you are not very well versed. Like for people transitioning from mechanical engineering to computer science, it's all right. Like it's completely a fine decision to do. You should be just aware of your motives and be willing to put in that work. And most of these things are actually very, very simple. There's a lot of jargon and there's a lot of technical terms surrounding it, but a lot of the ways in which these companies work are actually very, very simple solutions done multiple times. So don't be afraid in exploring some new fields. And yeah, that's something I would recommend. Yeah.
Keep it simple and keep working towards it. You will get eventually. Perfect. Thanks, Sagar. Thanks a lot. Won't hold it further. It's Saturday evening over there. Anyways, hectic week given the kind of work you are in. So, thanks a lot. I'm sure a lot of students would be definitely benefiting from what you have shared. I think it opens up the mind. The way we perceive companies, the way we perceive the work over there, and we have a picture of our own in our mind, thinking, okay, this is how it works. But speaking to someone who's actually implementing things for billions, definitely would give them an idea of what and how a person works over there, and then what they should be looking at. So thanks a lot. Thanks again for joining us, spending time, and yeah, take care. Have a good night. Bye bye.
You too, man. Have a good day.
Okay, that was Sagar, guys. I hope you had a lot of learning to take away with you. Definitely something you should focus on, which he mentioned, is on problem solving. Okay, and that's something which is definitely the key to all the solution. And keep looking out for solutions, keep looking out for options, keep talking to people, keep attending talks like these where you get more insights. And with this, I would leave for now as well. Have a happy Sunday. Quick updates: today evening we have a scholarship test, and next weekend we would be starting with our ML bootcamp. Okay, and there would be one or two sessions in between as well. Don't forget to join them. Don't forget to refer to your friends. Why have all the fun yourself? Why not include everyone else and help them grow as well? Because these are the sessions which usually you don't get in college. These are the learnings which you usually don't have in college, and people are at the top of their work. So with this, I'm signing off. Hope you had a good learning, good time. Take care. Have a good day. Bye bye. Keep learning, keep exploring.